This presentation starts off by giving you some tips on how to solve a balance problem in chemical engineering. Okay, I know you will be solving this in a test, or an exam, but invest some time in making sure you read and understand the question. If you are unsure, ask an invigilator what is meant by a section of a problem. Is it a flow rate? Or a composition? What are the units requested? I think this is very important. It also helps to get a picture in your mind of the process. This will help make the picture in your mind even more clear. If you are not given a flow rate, or an amount, you may have to choose a basis, such as 100 kilograms. Draw a dotted line around your plant or processing unit. This will help you identify which streams go in and which streams go out, giving you the values you need to enter into the general balance equation. By the end of this presentation, you should be able to do the total, and the component, balances, for the boundary that you specified in the previous point. After you have read the problem and determined what is required for the answer, it is time to set up the flow sheet. This slide will help show you how. A process is often represented by a rectangular box with description. Process streams are represented by lines with arrows indicating the direction of flow, in this example for the feed you have. And for the product stream. For the feed, use capital F, and for the product, use capital P. Draw a dotted box for the mass balance boundary. See how stream, F, crosses the dotted boundary line, allowing reagents to feed into the process, as indicated by the arrow. You can also see that stream, P, crosses the boundary, allowing products to flow out of the process. This slide will show you how to label streams. An example could be a mixture of hydrogen and nitrogen gas. This feed stream, F, has a flow rate of 100 kilograms per second. In F, the mass fraction of component A is 0.5. Hence 50% of the stream mass consists of component A. In this example, the subscript is F, A. Capital F for the stream name, and capital A for the component. Note that if you add the mass fractions of all components, you should get 1. Can you say what the mass fraction of B is in stream F for this example? What do you think? Have you got an answer? If you said 0.5, you are correct. Hit pause and try set up this diagram by yourself. If you are ready, press play again and see how you fared. The product stream is given as 3000 kilograms of a 10% slurry. The product stream will be denoted by P, equal to 3000 kilograms, with calcium hydroxide mass fraction of 0.1. The mass fraction of water is not given. The product stream consists only of calcium hydroxide and water, hence XPC plus XPW is equal to 1. Hence XPW will be equal to 0.9. You need to dilute a feed of 30% slurry. Dilution means adding water to a feed, F, which has a mass fraction of 0.3, and an unknown flow rate. F only contains calcium hydroxide and water, as the diluted slurry only contains these two components. Hence, as XFC is equal to 0.3, then XFW must be equal to 0.7. For the dilution, there needs to be a second feed stream, consisting of water, named W, with an unknown flow rate. What will the mass fraction of water be? XWW is equal to 1. If you picture the process, you may realize that the two feed streams need to be mixed. The process is therefore mixing.